Hello and welcome back to Calculus 2, Introduction to Section 7.3. I'm just going to talk briefly about things that you need to work on and ruin your weekend, right? So you can prepare well for what's coming up next week. So next week we'll cover 7.3 trig integration and 7.4 trigonometric substitution. Both sections have word trigonometry in the title, which is where you are going to use all of the formulas which I mentioned in our review on day 1. First of all, I need to make sure that you know your calculus pairs. So calc pairing. Sine with cosine, secant with tangent, and cosecant with cotangent. That is extremely important because you are not going to have a problem that will say sine cotangent. You will convert the cotangent into cosine over sine and then deal with that. So you need to know trig pairing. You also need to know the trig, well, you know the tangent, sine over cosine, all that kind of stuff. You also need to know the Pythagorean identity, sine squared x plus cosine squared x equals 1. And then if you divide through by cosine squared, you get tangent squared x plus 1 equals to secant squared x. And if you divide through by original equation by sine squared x, you get 1 plus cotangent squared x equals cosecant squared x. Now each one of these can be solved, right? This one for sine squared x and cosine squared x. So there are technically 9 formulas here. You divide, that's how you prove, right? You divide here by cosine and by cosine and by cosine, and you get this equation. Then you divide the first equation by sine squared, sine squared, sine squared, you get the second equation. That's for those of you who would like to remember how to get them rather than remembering formulas. What else are we going to use? 100%. Sine 2x is 2 sine x cosine x. No question about that. 100% there. Cosine 2x is equal to cosine squared x minus sine squared x. And I'm just going to point the arrow here. 2 more. Because you can replace cosine squared x with 1 minus sine squared x. And then the cosine 2x equation becomes 1 minus 2 sine squared x. So there are 2 forms that would help you with that. And the almighty power reducing, which is what you guys already seen. So sine 2x is 1 minus, so sine squared x is 1 minus cosine 2x over 2. And cosine squared x is equal to 1 plus cosine 2x over 2. So power reducing formula is extremely important. And then from there, you have the list that you have to memorize of derivatives, and then that same list read backwards is the list of integrals. And that would conclude the whole thing. So you will memorize that derivative of sine x is cosine x, which says that the integral of cosine x dx is sine x plus c. The derivative of cosine x is negative sine x, which means that the integral of sine x dx is negative cosine x plus c. Derivative of tangent x is secant squared x, which means that the integral of secant squared x dx is tangent x plus c. the derivative of cotangent x is negative cosecant squared x, which means that the integral of cosecant squared x dx is equal to negative cotangent x plus c. Two more. The derivative of secant x is secant x tangent x, which means that the integral of secant x tangent x dx is equal to secant x plus c. Finally, the derivative of cosecant x is negative cosecant x cotangent x, which gives us the integral of cosecant x cotangent x dx as negative cosecant x plus c. Whew. So you see that you learned the derivatives and you can read it backwards. It's an integration table. Now, to remember this easier, you see that sine is always with cosine, tangent is always with secant, cotangent is always with cosecant. Then if you look, every other line is negative. The derivative of functions, right? Cosine, cotangent, cosecant, right? So the derivatives of functions are all negative. We go on that? And then finally, do the pairing. Sines and cosine, right? And then look, secant squared, cosecant squared, secant tangent, cosecant, cotangent. So those are the pairs, the way it goes. Practice problems to enjoy your weekend would be expand sine to the 4x using power reducing. Now, to make your life easier, something like that should be practiced over the weekend. Some of those. If you have PreCalculus book or access to PreCalculus book, or you can't go to tutoring center and borrow the book for a second, you can find more of these problems where you should expand. The way to integrate sine to the 4th will be to expand and do a whole bunch of these. So try to expand it up to the point where you have no exponents anywhere. It's not going to be 2 lines. And then realize that on Monday we're going to slap integral on top of that entire calculation. So, 5 days of intense trig review will do a great, right? The SI sessions are on Thursdays, also on Wednesdays. Today's Wednesday, yeah. So your exam will be reviewed, right? Hopefully. Unless you don't want the review or the exam, you can just go and practice trig and practice other stuff. But Chris is willing to go to any example from the exam and explain to the gory detail, right, of what happened there, and maybe offer alternative approach if the one that I used is not something that you like. That's it. See you all in 5 days.